Okay, so let's look at some questions from the Lesson 9 problem set. Lesson 9 is just more of the same from Lesson 8. It's still reading a situation from a word problem, identifying some quantity that you want to represent as a variable, perhaps writing some other quantities in terms of that variable, building an algebraic equation with that variable, using the properties of equality to solve for that variable, and then possibly having to determine what the other quantities were afterwards. So I've assigned a few questions. I'll do some of them for you. Let me see if I can identify which ones look the hardest, and then we'll do that. Let's do number 2. So I'm going to cross out this 1 right here, and I'm going to write number 2 because this is question 2. And it says, Michael is 17 years older than John. In 4 years, the sum of their ages will be 49. Find Michael's age. So they told us a little bit about Michael. He's 17 years older than John. They didn't tell us anything about John. So my recommendation is to make J your variable for John's age. And then we're going to write Michael's age, who's 17 years older, in terms of J. So that means that J plus 17, because he's 17 years older, that's going to equal Michael's age. This is a relatively simple question, except for one little tricky part of it that I could see messing some people up, and that's why I wanted to do this one for you. So it says the sum of their age will be 49 in 4 years. So in 4 years, John will actually be J plus 4 years old. Right? J plus 4 equals John's age in 4 years. And J plus 17 plus 4. Oh, sorry, I just realized I'm kind of off the screen. So J plus 4, that's John's age in 4 years. And J plus 17 plus 4, that would be Michael's age in 4 years. So J plus 17 plus 4, or J plus 21, that's Michael's age in 4 years. I've been doing a lot of writing today. My handwriting looks really bad right now. I apologize for that. So essentially, what tricks people up on this question a lot is they think, okay, I'm supposed to add John's age and Michael's age, which is J plus 17, and then they add on an additional 4 for the 4 years. But I think what they fail to realize is that both people are going to age 4 years in that 4 years, and so we really need to add on an additional 8. And that's where this 4 and this 4, they're going to take care of that for us. So now I'm going to do John's age in 4 years, which is J plus 4, plus Michael's age in 4 years, which I'll write as J plus 21. I'll combine the 17 and the 4. That's supposed to equal, I gotta remember again, I forget this stuff easily. It says 49. I'm gonna combine like terms on the left side of my equation. So I have 2J plus 4 plus 21 is 25 equals 49. So I will subtract 25 from both sides of this equation, and I have 2J equals, is that 24? Yep, 24. So I will divide both sides of the equation by 2, and I arrive at the solution J equals 12. So John is currently 12 years old. So don't think that this means that John will be 12 in 4 years, because we set J at the very beginning to represent John's age, and because we set it up well from there, all we have to do is go back and look at how we define the variable, and that tells us exactly what it is. So John is 12 years old. What was the question asking though? It wants us to know Michael's present age. So John is 12 years old. So Michael is, well, Michael's age is John plus 17. So 12 plus 17 equals 29 years old. Right. Oh, sorry about that. I think I'll do number 8 for you next. Number 8 looks like it could be challenging for some people. So I'll cross this out. All right, number 8. It says, Aiden, let me put this on the screen so you can see it. It says, Aiden refills 3 token machines in an arcade. He puts twice the number of tokens in machine A as in machine B. Okay, so they told us a little bit about A. And in machine C, he puts 3/4 what he puts in machine A. So they told us a little bit about C. The 3 machines took a total of 18,324 tokens. How many did each machine take? They did not tell us anything directly or indirectly about machine B. So I'm going to make machine B my variable. And I'll just use the letter B. Let's see if we can get this straight. So I'll set my variable as B equals number of tokens in machine, I'll abbreviate that as MAC, in MAC B. And now let's see what they told us about machine A and machine C. It says he puts twice the number of tokens in machine A as in machine B. That one's easy. So that means that 2B, 2 times however many there are in B, that equals, I'll just write tokens in A. That's a little bit easier, I think. And then the last thing, they said something about machine C. It said he puts 3/4 of what he put in machine A. So we have an expression for how many tokens are in machine A. It's 2B. So he puts 3/4 of that, 3/4 times 2B. That's how many tokens are in machine C. Now we just have to add these things up, and they have to equal 18,324. So we have B plus 2B plus 3/4 times 2B equals 18,324. So let's combine all these B terms. First, we have to multiply these 2 factors here to get a coefficient of this third B. Well, this is just 2 over 1, so 3 times 2 is 6, 4 times 1 is 4. So what we have here is B plus 2B plus 6/4, which is the same as 3/2. 3/2 B, and that still equals 18,324. And so now I can add these up. B plus 2B, that's 3B, plus 3/2 B, or essentially 1.5 B, if you prefer to think of it that way. We have a total of 4.5 B. I'm probably going to use a calculator to do this final division, so I'm going to write it in terms of a decimal. 4.5 B, I can make sure I did that right. 1B, 2B, that's 3B, plus 1.5. Yeah, 4.5 B equals 18,324. And so I'm going to divide both sides of this by 4.5. And that's going to tell me how many tokens are in machine B. And yes, I am going to use a calculator to do 18,324 divided by 4.5. It comes out to 4,072. I'm going to leave it up to you to figure out how many tokens are in machine A now, which is 2B, and how many tokens are in machine C, which is 3/4 of 2B, but you will have already figured out what 2B is because you had to figure out how many tokens are in machine A. So it's just 3/4 of whatever you get when you do that. And I'm going to leave that to you. And I'm going to do question number 9. It says, put it over here for you. Polly ordered 250 pens and 250 pencils to sell for a theater club fundraiser. The pens cost 11 cents more than the pencils. If Polly's total order cost $42.50, this number comes up a lot in these books, I'm just noticing. They love $42.50. Find the cost of each pen and pencil. All right, so they told us that the pens cost 11 cents more than the pencils. And so they didn't really tell us much about the cost of the pencil. So I'm going to make a variable to stand for the cost of the pencil, and I'm not going to use P because I'm dealing with pens and pencils, and so using a P could get kind of weird. So I'm just going to use good old X. X will be the cost of a single pencil. And so since a pen costs 11 cents more, I'm going to say that 11 plus 0.11. That's 1100ths, not just the number 11, because then you're going to be working in dollars and mess yourself up. X plus 11 cents, that equals the cost of a pen. And it said that they bought 250 of each of these. So 250 times the cost of a pencil plus 250 times the cost of a pen, which is the quantity X plus 11 cents. That has to add up to this magical number that they love so much, 4250. And so I'm going to use the distributive property here first. I'll just keep this 250x the way it is, plus 250x. I'm distributing this 250 to the parentheses here. I'm doing this stuff. And 250 times 0.11. Well, let's see here. If it was times 0.1, that would be 25. But I have this extra 0.01 here, which would be 2.5. So I'm pretty sure this comes out to 2750. But I don't want to write the wrong number in my video here. So I'm going to do 250 times 0.11 equals, yes, it is indeed 2750. And that is still going to equal 4250. So now let's combine these x's. We have a total of 500x. And we're still going to add 2750 to that. And that's still supposed to equal 4250. And now that we have the left side of this equation in standard form, let's subtract 2750 from both sides. And so I'm still going to have 500x on this side, but the positive and negative 2750s will cancel each other out. They make zero, they're additive inverses, whatever you like to think, however you like to think of it. So I look at this 4250 minus 2750, and I think, okay, to get from 27 to 42, well, 10 would get me from 27 to 37. I need another 5 to go from 37 to 42, so that's 15. And then these 50s will just sort of cancel each other out when I subtract down. So this should be 15. And we're working in dollars. This is $15 here. And so when we divide both sides by 500 here, I'll use a fraction bar to indicate division. We're going to get x equals whatever 15 divided by 500 is. It's going to be a small decimal because we're going to be back working in cents, which makes sense because a pencil should be a couple cents. It adds up when you give thousands of them to your students over the course of a year. I'll tell you that from personal experience. But anyways, 15 divided by 500 equals 0.03, or 3/100ths. In other words, 3 cents. So each pencil costs 3 cents. I could write it as $0.03, or I could write it as 3 with the cent sign. I think I usually do the $0.03. So just to mix it up, I'll use the cent sign today. And that means that the pen is 11 cents more than that. So pens are 14 cents each. All right, I'm gonna leave the rest up to you. That's it.